have this LST here, right? I have this list from 1 to 10 numbers. Now this particular dot reverse function, what this will do is it will basically reverse all the elements in the list. So if I have from 1 to 10, when I do LST dot reverse, it will make sure that the numbers are from 10 to 1. That is, it will just change the order. So when I call this function, the important thing to note is when I do shift tab on this inside the function, when I press a shift tab, I will get what this function actually does. So it says L dot reverse, reverse in place. Now we should know that in Python, in place stands for it will modify the list or modify the data structure and store it back in the same data structure. This is what it does. When I say in place in Python, it means that it will modify the list and place it back into the same data structure. So in this case, if I have LSD, right, and then next I will say LSD dot reverse. Now to get the function or for auto completion, what you should do is press dot after your list and then press a tab. This tab will give you all the functions that you can do with this particular list. I have clear, copy, count, extend, insert, pop. We have seen all of this. Now we need to see remove. So if I press a dot and type REM and again one more tab, it will auto complete. Okay. Now what this does is if I do LST dot remove, replace, reverse. Now what this will do is it will actually reverse the list and store it back in LST. So if I execute this and after this, if I print my LST, we see that the elements have been reversed. Previously it was 1 to 10, now it is 10 to 1. That is what list.reverse will do. It will reverse the elements in the list. It's clear, right? Reverse. Any doubts in reverse? Dot reverse. And you should remember that this particular function is in place. So let's list dot. Let's see. So what this will do is it will reverse the list in place. And when I say in place, it means that it will modify your data structure or lift and store it back in the same list. So we did list.reverse and in place. Any doubts in these two?
Why is that if we make this function inside another variable and print that, it is giving none there?
Yeah, that is because this actually will not. See here, I can do this. Now I can since I have LST here, right, which is this. If I do lsd.reverse, it is not going to print anything. But if I do lsd.reverse and then print lst again, now we'll see that it's from 1 to 10. That is, it only works on the one data structure itself. So it will modify the list and store it back in the same list. But what we can do is we can actually store this. This should ideally work, but it was not working. Let's just check. This 2 equals lst.reverse. Yeah, that's not working because this is an in place function. When I say in place, it means that it will only work on this LST itself. Now if you want to assign it, then you can do this. Just initialize LST again. Yeah, now if I do lsd.reverse and I print LST, I see that it is from 10 to 1. Now I can actually do lst2 equals lst. Now if we print lst2, it will have 10 to 1. But you cannot create a new list and then assign it to reverse of the other. Directly, yeah. You'll have to first modify the same list and then reassign it. There is another way also you can do it. We will see that in NumPy. We won't be using this much because these are very primitive functions. Once you start using NumPy, you will see that it's far more easier. But for now, we should know the reverse function in Python, and that is that it is in place. Is clear? Reverse and in place. Now if I want to sort a particular list, now I have LST, right, which is in descending order. If I do a sort, now the same thing happens with sort also. It is an in place function. As you can see here, it says in place. So it will always affect one data structure itself, that is LST. Now if I do LST dot sort, it has actually modified LST itself. Now if I print LST, we see that it is back to ascending order. Now when I'm sorting, you have one particular option called reverse equals false. This is an argument in this function for sorting. Sorting is basically arranging in ascending or descending order. By default, if I don't pass any argument, it's always in ascending order. It sorts in ascending order. Now when I say reverse equals true, it will sort in descending order. This is what happens. So dot sort function for any list, if I don't pass any argument, it will sort in ascending order, and this also is an in place function. So list dot sort is also in place function, and if reverse equals true, then it will sort in descending order. So this is your list dot sort function. If I don't pass any arguments, it is going to sort in ascending order. If you pass argument saying reverse equals true, or if you pass the reverse argument, by default it is set to false. By default it's always false. If I set it to true, it means that it is going to sort in your descending order from largest to the smallest. Ascending is smallest to the largest. Now we will see what exactly is the difference between a shallow copy and a deep copy. Shallow copy versus deep copy. When I say shallow copy, one of the examples for this is, if I say x equals 5, what exactly is happening inside is, I mean in your memory location or in your hard disk is, at say some position like let's say 10011, there will be a memory location of because it is an integer, we'll have say 32-bit integer, and at this location a value of 5 will be stored. Now when I also say, when I do a shallow copy, that is I am also creating a new reference to the existing variable. That is, I have x equals 5. So in your hard disk, at locations, some location, say 10011, we'll have the value 5 stored. When I'm creating a shallow copy here, that is, I am just creating another reference to the same existing memory location. When I say y equals x also, then your 10011, which has the value 5, can be accessed using both y and x. That is, both x and y will point to the same memory location. That is the definition of shallow copy. That is, a new memory space is not assigned. That is the meaning of a shallow copy, that you are just creating a new reference to an existing memory location. Like here 10011 has the value 5 stored when I say x equals 5. When I am creating a shallow copy, so this is a shallow copy. What happens here is, a new memory location is not created, but to the same location a new pointer will be assigned, or you will just have a new reference to an existing memory location. That is the definition of your shallow copy. Now we'll see what exactly are tuples. So we saw lists, what exactly were lists, and we saw all the operations with them. The next data structure is called as a tuple. Now how is it different from a list is that it's actually a list, or it's similar to a list, but the only difference is that the elements in a tuple cannot be changed, or they are immutable. You cannot change the elements, or you cannot add or remove elements from a tuple. They are fixed elements. That's the definition of a tuple. Now, how to create a tuple? So one small example is you can just use to define a tuple, a variable is assigned to a simple parenthesis or as a tuple class object. So one way is I can say tup equals just parenthesis. This will create an empty tuple. One way of initializing a tuple. The other one is I need to create an instance of the tuple class. So I need to say tup equals tuple, and again it will have your bracket. So these both ways are valid ways of creating a tuple. Now we see that I've created tup and tup2, two tuples using two different methods. Now to validate that they're actually tuples, we can check the type. So if you check type of tup, it will say tuple, and type of tup2 also it will say, it will call it is also a tuple. Now what this will do is it will create a particular tuple and of numbers 1 to 7, and it will store in tup3. And now if I actually execute this cell, we see that I'm printing the tuple 3, which has 1 2 3 4 5 6 7 6 7, and I'm also checking the type of that particular data structure. I see that it belongs to class tuple. So tuples are exactly similar to lists, but the only difference is that the elements in a tuple are immutable. You cannot change the elements. That's the only difference. Now, for example, I have tup3, right? I have this particular tuple. Now if I try to append, or if I try to do any kind of functions or operations on it, it's not possible. All I can do is I can count, or I can get the index of the elements. So if now so with tuples we have only two functions associated with them. The first one is tuple.count, and second one is tuple.index. These are the two functions only two functions you can perform on a tuple. Now if I have my tup3, right, which has 1 to 7. Now I want to know the index of the fourth element, right? I want to know the index. So the first function here is dot index. So what this dot index does is, if I write the tuple name and I do a dot, if I pass any element, what this function will return is the index position of that particular element. Like in this case, the index position of 4, it's saying that it is 3 because it is 0 1 2 3. Now index position of 7 will be 6 because it is 0 1 2 3 4 5 6. So dot index, what your dot index does is it returns the index position of the element that you pass. So if I pass any element, it should return the index position of that particular element. That is what tuple.index does. Now tuples, because they are similar to lists, they will follow the same indexing and slicing. So I have tup3 here. Now if I want the first two elements, again we have seen this last class, I need to put a colon, and if I don't specify anything in the beginning, it means that I'm selecting from the starting, and if I want till the fourth element, I have to specify till 4. That will give me from 0 1 2 3 because it is till n-1. Remember this from last class, the indexing. So this is slicing basically. Indexing is just if I want the fourth element of the tuple, it will give me the since it starts from 0 to n-1, the fourth element is 5. 0 1 2 3 4. Right, this is your indexing. The slicing, all those rules which are applicable to lists are also applicable for tuples. So here if I just don't specify any start and end, it is selecting all the elements. If I don't give an end and I just say 4, it will select from the fourth index till the end, 4 5 6, 3 elements, right? So all those functions with lists, your indexing and slicing also hold true for tuples. So it follows the same indexing and slicing as lists. Right. Now, if I pass any string to a tuple, like here tup4 is some name, something like hello Bangalore, which has two strings. If I am trying to put them in a tuple separated by one space, what a tuple does is it basically separates every character in the string and puts it as a new element in the tuple. So here I have hello Bangalore, which has 1 2 3 4 5 and some 8, so 13 characters plus one space, 14 characters. Now what this tuple function will do is every character is treated as a different element in your tuple. So now if I actually print tup of say 4 or ray of 3, tup4 of 3, I got L, that is 0 1 2 3, right? So the element at the third index position is L. So what you should know is whenever I pass string characters or string elements to a tuple, every character in that string is treated as a separate entity or as a separate element. Even the space, here the space is also treated as a unique element. If I give say 5 spaces, I have 5 spaces here. So every element in that particular string is treated as a character. This is what you get if I create a tuple with anything you create. It will always split it into respective characters, and the length of the tuple will also be 28 because it is treating every character as a separate entity. Is clear? Tuple characters, rather strings with tuple. Okay. This is not required. Now, how do I create two-dimensional tuples? So there we saw that tup3 and all were single dimensional. That is, it just had one element. Now I am trying to create a tuple. Let's say I create with numbers only 2 3 4, and as a second element I have 5 6 7. Now I have created A. If I actually print A here, we see that we have a two-dimensional tuple because as an argument to tuple, what am I passing? So I have two lists here, and as an argument I am passing two lists as a list itself. So this particular two lists being put in a list. Now this element becomes a list of lists, right? Now this whole thing I am passing to create my tuple, or I am passing as my input data to the tuple element. Now if I do this, I see that A has 2 3 4 and 5 6 7. So that means A of 0 will have my first element, exactly similar to your lists. Now how do you access 4? A of 0 of 2. So it follows the same indexing as lists. Double indexing or nested indexing, you can say. So all those rules which are applicable for lists are also applicable for tuples. You could have 2-dimensional, 3-dimensional tuples and so on. So for 2-dimension, I'll just have to create one more double list. So this itself, the whole thing should be one list. So this list, and this whole thing has to be one particular list. I think this should work fine. Yeah, so this becomes a 3-dimensional list. So A of 0 will basically give you this particular element. Now A of 0 will give you 2 3 4, and A of 0 of 0 of 0 will give you 2. So this here I am creating a 3-dimensional tuple, right? This stands for your first element, and this is your second element in one dimension, and then your second dimensional elements, which are these two lists, and then your third dimension is your actual list. So a of if you just see a of 0 will give you this first element, which is 2, 3, 4 and 5, 6, 7. This is your first element. Next, if I get into the next nested index 0 of 0, that should ideally give you the first element of this, which is 2, 3, 4 is what I'm getting here. Now if I do 0, go one level more inside, I should get 2, which is the first element of the first element of the first element. This is how we will create multidimensional tuples. And always you should know that whenever you are creating a tuple, it will only take one argument. That is why I cannot create a tuple like this. If I try to create a tuple and I pass two lists, right, 2, 3, 4 and then comma some other list saying 4, 5, 6, it will throw an array saying it takes only one argument at most. So you can give multiple lists. All you have to do is you have to put this entire thing in one data structure, either a list or an array or anything. I mean, not this would be this way. I have one extra bracket, so this is not required. This is what we have. So it'll always take one argument, and inside that one argument we can always give multiple arguments. The same thing for list also. A list cannot take more than, whenever I'm creating a list, I can take only one object. I can pass only one object, like list of 1, 2, 3, 1 to 4, this will work. But if I say comma one more list 2, 3, 4 or 2, 4, 5, it's going to throw an error, because it can maximum take one argument. But if I want to pass two lists into one list, or if I want to add or convert the two lists into a single list, then both of those two lists should be inside one list. This will work. The same with tuples also. Tuples are clear. So what they can ask you is, they can ask you what exactly is a tuple, how is it different from a list, how to create single dimensional tuple, how do you work with strings using tuple, and then finally how to create multi-dimensional tuples as well, how to access elements in tuple, and index and count. More than this they are not going to ask you. I mean, I'm talking with respect to the interviews you might face later on. So these are 7, 8 questions, but the use cases of tuple you will see when we start the actual statistical modeling and other things. You will see how useful they are, because you cannot change the values in a tuple. So we saw what count does, we saw what index does, right? Now we will jump on to sets. Now what exactly is the whole point of a set is, sets are mainly, at least sets in Python, they are mainly used to eliminate repeated elements in any data structure, be it a list or a sequence or an array, things like that. So they are mainly used to remove duplicate or repeated elements in a data structure. It is also used to perform some standard set operations. I think you are aware of intersection of sets, union of sets, difference, subset, disjoint sets, and all these things. So we will see all of those. So to create a set, we just have to use the set variable. So you can note down this particular definition for a set. Right. Now to create a set, or how to initialize a set, it's using the set keyword, and I have to pass set of 1, 2, 3 if I create, or I need to pass a data structure here. This will create set of elements. Now the biggest use of set in Python is, suppose I have a list called L, and L is nothing but a lot of repeated numbers, right? And then I have so many of these repeated numbers and so on. Now this is your list which has a lot of repeated integers. Now the whole point of set is, if I do set of L, what we saw that it will only give you those numbers which are unique, right? So set of L will give you the set of unique elements in a particular data structure. Like in this case, it says that all the unique elements that are there in this particular huge list are only 2s, 3s, 4, 5, 6 and 54, and that is in fact 2. We don't have anything other than this. Most of them are repeated elements. 2 is repeated so many times, 3 is repeated so many times, 5, 6 and so on. So what set does is, it will give you the set of unique elements in any data structure. That is the first use case of your set function. It works with strings also, because I have this particular, suppose I have a string called names or a list called names. I have A, and then I have AA, let's say, and then I have B, and then I have BP. So I have 4 names here. Let's also repeat them. I will going to type A again and BB. So I have names. So if I print names, I'm going to get the same elements. But if I do a set of names, I see that I will only get all the unique elements that are present in my list. So that is the first use of set. Is clear? Set, how does it work? Not clear? Not clear? Is it clear? Or? Now there are a few built-in set functions. I think you are aware of what dot union does. It will give you the list of all the elements that are present in both the lists. Suppose I create 2 lists here, set 1 and set 2. Set 1 has 1, 2, 3, set 2 has 2, 3, 4, 5. So if I want to perform any operation with set, as usual I have to press a dot and your tab. So this will give me all the functions that I can perform with my set. So I am only interested in union now. So set1 dot union of set 2, what this gives me is, it will give me all the unique elements that are present in both the sets, right? To explain this, I think paint I can try. Right, so this is your set A or set 1, and this is your set 2. What union does is, it gives you all the elements that are present in both the lists. So it covers every element that is present in the list. This is your union. When I talk about intersection, it is this particular region, which is the elements that are common between 2 sets is what is shown in dot intersection, right? So union and intersection. Union will give you all the elements that are present in both the sets, whereas intersection gives you only this region, which is the intersection of the 2 lists. So we'll just see intersection also. So we saw union here, and here also we should make sure that when I do any operation on 2 sets, the resulting data structure is also a set. If I check out the type of this, is also a set, because I have set 1 and set 2 and I am performing an operation on the 2 sets. The type of the resultant data structure is also a set. If you're not following if you don't follow anything, please ask me. I'll repeat it. So we saw that whenever I perform any operation on any 2 sets, the resultant data structure is also a set. So union function, what it does, it will return a set which contains all the elements of both the sets without any repetition. Now, unlike tuples, sets are not immutable. That is, you can actually add and remove elements from a list. So your add function will basically add a particular element into the set. So if I do set, we have set 1, right? We have set 1, which is 1, 2, 3. Suppose I want to add 4 more elements to this, then I have to say dot add, and I can pass, say, one element. I want to add the element 5. Set dot add of 5, and if I check set 1 now, I see that element 5 has been added. Suppose I want to add another element 6. Now I have 1, 2, 3, 5, 6. That means sets are basically immutable, or they are mutable, unlike tuple. That is, when I say that they are mutable, it means that I can actually modify the elements in the set. I can add, I can remove, and so on. So we saw union there. I have set 1, 1, 2, 3, 5, 6. I have set 2, 2, 3, 4, 5. Now if I do set 1 dot intersection of set 2, I see that I'm getting only 2, 3, 5. Now what intersection does? What does this do? Common elements between the two sets. Simple as that. Now always remember that even if I do set 2 dot intersection of set 1 or set 1 dot intersection of set 2, the resultant will always remain the same because the common elements will not change. Correct? Now the other one is difference. This particular difference function, what it does is it will output a set which contains the elements that are there in your set 1 and not in set 2. Like for example, if I have set 1 here, right? I have 1, 2, 3, 5, 6, and I have set 2 which is 2, 3, 4, 5. If I do set 1 dot difference of set 2, I am getting only 1, 6. It means 1 and 6 are the only two elements which are there in set 1 and not there in set 2. Is clear? See, I will print set 1 also here. I have set 1 which is 1, 2, 3, 5, 6. Set 2 is 2, 3, 4, 5. When I take a difference, I am getting only 1, 6 because 1, 6 because 2, 3 and 5 are actually present in set 2 as well. I am only interested in finding out those elements which are there in set 1 but not in set 2. That is what set 1 difference set 2 will give you. Set 1 difference set 2 will give you those elements which are there in set 1 but not in set 2. Now if I do set 2 difference set 1, what can we expect? 4, because only one element is there in set 2 which is not there in set 1. Is clear? Difference? Now we saw difference. Now there is something called symmetric difference. This particular symmetric difference function will output a set which contains elements that are there in either one of the sets. There, when I took difference, right, I got, if I did set 1 dot difference of set 2, I got those elements which are there in set 1, not in set 2. But what your symmetric difference will give you, say, in this particular set, I have 1, 2, 3, 5, 6, right, is in this position, and your intersection is 7, 8, right, and here it is 11, 22, and 34. 11 and 22 will take. So I have these numbers here. Now when I do set 1 dot symmetric difference of set 2, it will give you those elements which are there in only one of the sets. So it is exactly the opposite of intersection. Intersection will give you 7 and 8, right? Whereas symmetric difference, we can actually write them down here. If I do set 1 dot difference of set 2, then my output is what? What will I get here? If I do set 1 minus set 2, which are there in set 1 and not in set 2. These, right? I am going to get 1, 2, 3, 5, 6. 5, 6. Similarly, 3. Similarly, if I do set, in the same way, if I do set 1 dot symmetric difference of set 2, this will give you all those elements which are there in only one of the lists. So in this case, I will end up with 1, 2, 3, 5, 6 and 11, 12. That's the only difference. So I'll get 1, 2, 3, 5, 6, comma 11, comma 12. That is your symmetric difference as well. Difference is it will give you those elements which are there in one set and not in the other, whereas symmetric difference will give you those elements which are only there in one of the lists, one of the sets. So similarly here, if I do set 2 dot symmetric difference of set 1, I see that I am getting 1, 4, 6. That means these elements 1, 4, 6 are present in only in in either set 1 or in set 2 and not in the intersection region. Yeah, so we have seen till set 1 dot difference of set 2, and we also saw what exactly does symmetric difference give. You should always remember that the output of all these set functions is also a set, right? So if you check the type of any of these, it will always be a set. Next we have three functions: is subset, is disjoint, and is superset. Now they are used to check, and when I say check, they will always result in true or false. So they give you true or false values as the answer or as the output. Here is subset will check if I do set 1 dot is subset of set 2, it will check if set 1 is a subset of set 2. If it's true, it will return true, else it will return false. Like here it is not, because set 1 has some elements which are not there in set 2. I think you know the meaning of subset, right? Subset is all those elements which are there in the bigger set. Is disjoint, it says false. Any idea what is this? I forgot. Disjoint, no one remembers. Yeah, no element in common. Yeah, so is subset will check if the first set is a subset of the second. Is disjoint will check if they have any elements in common, and this is the opposite of subset. When I say set 2 dot is superset of set 1, it will check if all the elements of set 1 are there in set 2. Whereas if I do set 1 dot is subset of set 2, it will check if set 1 is a subset of set 2. Here it will check if set 2 is a superset of set 1. That is, if it contains all the elements that are there in set 1. These are straightforward, I think. Subset, is disjoint, and is superset. These will always return Boolean values, true or false. Again, set dot pop, it will remove the last element in your set. Like here we have set 1, which is 1, 2, 3, 5, 6. If I do just a small pop, I see that the first element is removed here and not the last. It removes actually, now I have 2, 3, 5, 6, I do pop again, it removes the first element. Now I pop it again, I'm left with 5, 6, finally this. So your pop will remove, unlike list, it will always remove from the head of the set, the first element. But if you want to remove a specific element, then I can use dot remove. Like I can check with set 2. Set 2 has 2, 3, 4, 5. Suppose I want to remove the element 4, then I have to use set 2 dot remove, and I pass that particular element 4, and then I print set 2. So I see that 4 has been removed. So if you want, what dot pop does is, it will remove the first element from the set, whereas your dot remove function will not, it will remove the specified element from the set, right? So that is your dot pop and dot remove. Clear will remove all the elements. So if I do set 1 dot clear, I will basically get an empty set, because dot clear will remove all the elements in your set. If you want to add two sets, it can be done using dot add. So we studied what is pop. Pop will remove the first element. Dot remove will remove the specified element which you pass as an argument, whereas dot clear will clear all the elements in your set. That is about removing elements. Pop, remove and clear. If I want to add two sets, or if I want to add to a set, I can always add using my dot add function, which we have seen before. So this covers sets. So we have covered a bit of list functionalities, tuples and sets today. The other important thing is I couldn't send the assignment over the weekend because I was a little sick. So I'll send 3 assignments today. One for the basics of Python, second one for list, and third one for tuples and sets. So make sure you complete it by tomorrow at any cost. Okay. And what I'll be following for this week is tomorrow we'll be doing string and string operations, and then on third, which is Wednesday, we'll start with control flow statements. Control flow is if, while, control flow as well as your looping. We have 4 types of for loops, while and do while loops. This would happen on Wednesday, and I think functions. This would on Thursday we would cover functions, basics, and something called lambda functions. Right. So once this is covered, I think we'll be good to go with we can, this would be part of the advanced Python. So this is where, so this would, the next, by 4th I'll be done with basics of core Python, or core Python as you call it. Then we will jump to statistics. We'll cover from Friday till another 3 classes I would say, and then come back to advanced Python. So I think after next week we'll be done with the statistics part as well as Python. Next week end tak. So I'm guessing by let's say 13th or 14th of July we can start with predictive modeling, wherein we study linear regression and logistic regression. Okay, so these next 2 classes do not miss. These 2 will form your basic for almost everything, because so tomorrow, so 3 more classes for core Python, then statistics, then advanced Python 2-3 classes, and then we'll start with predictive modeling. And I'll send 2 assignments as well. Please do complete it. 2 assignments. Any doubts till now?